Hi there. Today let's look at solving inequalities. And the way that you solve inequalities is super similar to just solving an equation, and it's really more about how you answer at the end as far as what's going to be different. So I wanted to talk a little bit about that to open up with. In your software, sometimes they ask for algebraic notation, sometimes they ask for interval notation. So I thought I'd kind of make sure that we understand the difference before we jump into this, actually solving some. So if you had something like x is greater than 6 for your final answer. Okay, so what that means is you want that x can basically be anything as long as it's bigger than 6. Now, on this particular lesson, you're probably not going to do any graphing on number lines, but I kind of like the visual of it so it makes sense in your head what's going on. So basically what we're saying here is 6 is the smallest it can be, and then it can be anything bigger than that. Now it can't actually be 6, so we put a parenthesis to show that it can't really be 6, but it can be anything bigger than that. Alright, so you're going to see that algebraically like this as you're solving it, but as you progress through math you'll find that you do a lot more with interval notation. So interval notation always puts the lower bound, the lowest it can be, comma, the highest, or the upper bound, the highest it can be. Now we'll use parentheses to show less than or greater than, but we'll use brackets to show that it's an or equal to. So sometimes you'll use a parenthesis, sometimes you'll use a bracket, that will vary. So what I'm going to do is do a few examples where you see both types, algebraic and intervals. So if this were what it meant algebraically, which graphically would look like this, then to write that in interval notation, I would say the lowest it can be is a 6, but it can't equal 6, so we do a parenthesis. The highest it can be, well, it moves on forever to the right, so I put in infinity. Infinity is not actually a number, so I use a parenthesis. It will never actually equal infinity. Okay, let's try another one. Let's say you had something like x is less than or equal to negative 2. All right, so ignore all the pink stuff now. I'm going to blue. Okay, so that means negative 2, and then anything smaller than that would work. Okay, since it actually can equal negative 2, this time we'll use a bracket on that. And so it's negative 2 and everything smaller than that. In interval notation, when you look at what the lowest it can be, it actually moves on forever towards negative infinity. And then the highest it can be is negative 2. But since it's an or equal to, we'll put a bracket on that. The infinities are always going to be parentheses. Okay, let's try one more. Ignore the pink and the blue. This time we're going to use black. And let's say you had something like this, which we will have at the end. It'll be something like negative 1 is less than x, which is less than or equal to 3, let's say. Okay, so something like that would say, basically that says that x is bigger than negative 1, but it's got to be smaller than 3. So bigger than negative 1, but smaller than 3 would be anything in this range. So this has a definite lower and upper bound here. Now, because it's not an or equal to the negative 1, I'd put a parenthesis on that. But the or equal to on the 3 makes me use a bracket. So that should help us then to write this in interval notation, which means write the lowest it can be and the highest it can be. So the lowest is negative 1, but it's not an or equal to. The highest is 3, and because of the or equal to, I'll put a bracket. So those are the different types of answers that you're going to be using, and you really have to pay attention to the directions on which method they want you to use. Okay, so let's try some. Okay, so on this first one, I have an equation where I have z in multiple places. As I said, we really are going to solve this like you would an equation. So I'm going to add my 3z to the other side and get my z's together. So then 3 is less than or equal to 5z minus 6. And since my z's went to the right, I'm going to add the 6 to move it to the left. Numbers go one way, variables go the other. So 9 is less than or equal to 5z divide both sides by 5. So I have 9/5 is less than or equal to z. Now, I really kind of like to have the z on the left side so I get a better feel for what that looks like. So z, now notice that z is on the bigger side of your inequality. So z is actually bigger than the 9/5. So when I switch it around to put my z on the left, I got to switch that sign so it stays pointing at the right number. Okay, so then as far as that would be algebraic notation. If they wanted interval notation, and again, you're probably not going to do graphing so much, but just to visualize this, 9/5 is really 1 4/5, so I don't know, somewhere here-ish. And since it's an or equal to, it's going to have a bracket and all the z's that are bigger than that. So if they're asking for interval notation, I'd say that the lowest it can be is 9/5 with a bracket all the way to infinity with parentheses. All right, so that's all we're doing. Let's try a few more. Okay, just going to kind of gradually make these a little trickier as far as the solving process. The one thing that I didn't discuss, and it hasn't happened yet, and we'll see if it does, but the one thing that you have to worry about on inequalities that's different than equations is if you are ever multiplying or dividing by a negative number in the process of solving. So if you had something like negative 2x is greater than 4 or something like that, and so we would divide both sides by negative 2. If you divide by a negative or multiply, what happens is that switches the direction of that inequality. So now that x is going to be smaller than, and then go ahead and divide that out. Okay, so right there, when I divided by a negative, that's when you switch that inequality. So keep that in mind as we solve. That may pop up. So let's distribute. Negative 8x plus 10 greater than negative 2x plus 22. I usually try to keep my x term positive, so a lot of times I don't have to worry about that negative deal. So I'm going to add the 8x to try to keep the x term positive. So then I'm going to have a 10 is greater than 6x plus 22. Then I'm going to have to move my 22 to the left side. So I have negative 12 is greater than 6x. Last step, divide by the 6. Now my answer is negative 2 here, but I did not divide by a negative. The 6 was positive, so don't worry about switching the inequality for that. But I am going to do a little switcheroo on getting my x on the left side. So if I put the x on the left side, the x is actually smaller than the negative 2, so I got to keep it pointing at the x. So if I switch it around, I got to switch the inequality. Okay, so that's algebraic notation. If it asks for interval notation, then we need the interval where it works, and so negative 2 is my cutoff, and everything's smaller than that. Since it doesn't actually equal that, I'll put a parenthesis. So in interval notation, the lowest it can be is negative infinity, the highest it can be is negative 2. Parentheses on both of those. All right, the fractions are kind of the ones that tend to throw us off just because that is a little trickier to work with, so I thought I'd throw one that has fractions in it. This is actually not all bad. I'm going to get my x's together, and I'm in luck because when I'm adding these fractions, they happen to already have a common denominator. So a 3/4 x plus another 3/4 x is a 6/4 x. And then since I moved my x's to the left to keep them positive, I'm going to move my numbers to the right. So I have a 6/4 x less than or equal to 6. Okay, so on this step right here, to get rid of this 6/4, which I could have reduced, I didn't there, but I could have reduced that to 3/2, which would have been fine. But what I'm going to do is I need to get rid of that 6/4. So we multiply by the reciprocal. By doing that, everything's going to cancel nicely for me, but I got to multiply this side by 4/6 as well. Okay, The 4s are going to divide out to 1, the 6s are going to divide out to 1, and all I'm going to have left is an x. On the right side, since I'm multiplying by a fraction, it might be nice to look at that as a fraction. And so my 6s will actually divide out, and I just get a 4. So I guess it didn't hurt me to not bother with the reducing. The 6s reduced nicely. I have x is less than or equal to 4. Okay, so that means everything this way, since it's an or equal to, it'll be a bracket. So in interval notation, that would be negative infinity to 4 with a bracket on my 4 because of the or equal to. I thought it'd be important for us to do one of these. This looks very similar to the last one, but look at what happens. The very first step is to get those 2/3 x terms together. So I'm going to subtract 2/3 x, subtract 2/3 x. What's different are the signs this time, because my 2/3 x cancels out on the right side, but I also am going to get it to cancel out on the left side. So everything canceled as far as my variables. I don't have any variables left. So let's write what is left. We have negative 4 is greater than or equal to 9. Okay, here's the deal. If you lose the variable and it just totally disappears, you have two options. You're going to look at this right here and you're going to say, is that true or is that false? Okay, so if it's a true statement, so here's what you'd want to jot in notes. If you lose the variable, it subtracts out, divides out, whatever. You look at what's left and you have two options. If it's true, then that means it does not matter what you plug in for x, it's going to work. That inequality is just always going to work. So what we would do is we'd say all reals, or if it was an interval notation, you could say anything from negative infinity to positive infinity works. However, if the statement that you are looking at the end is false, well, that means it does not matter what you plug in for x, it ain't going to work. And so we would write no solution. There is no value we could plug in for x to make that thing work. Okay, so let's look at our situation. We have to look at this and decide, is that a true or a false statement? Well, negative 4 is not greater than or equal to 9. That is false. Okay, so then my answer on this would be no solution. Regardless of which method you're supposed to write it, it's just a no solution. Okay, I have one more. This one is what we call a compound inequality because there's multiple inequality symbols in this problem. Okay, that's actually not all bad. It's really kind of easy. What we do is we kind of look at it as an equation here and an equation here. It's two separate inequalities or equations, and what we do is we just solve them simultaneously. So what I'm going to do is I'm going to try to get x by itself. So I would typically subtract 3, but I'm going to subtract 3 over here and over here. We're doing this at the same time. So on the left side I'm going to have a negative 6 less than negative 2x less than 2. Next step, I'm going to divide. To get the x by itself, I'm going to divide by negative 2. But that means I got to do it over on this side, and I got to do it on this side. Now here's what's tricky. This is the first time it happened to us, but right here, I divided by a negative number. So remember, when you divide by a negative, you got to switch those inequalities. So this is actually going to turn into a positive 3, and instead of a less than, I'm going to put a greater than, and then an x, and instead of a less than, I'm going to have a greater than, negative 1. So what this is saying is that x is going to be smaller than 3, but it's going to be bigger than the negative 1. So that's going to be anything from negative 1 all the way up to a 3. Anything in there would work. Now, because they're not equal to, I'd have parentheses on both of them. All right, so a couple things. You're probably going to find that typically they like to list these in numerical order. Instead of having my bigger number on the left, we'd rather have the -1 over there so that it kind of follows the pattern of the number line. So you might see this switched around with the -1 on the left and the 3 on the right. But if you're going to switch that around, you got to switch those inequalities. So now that's less than, less than. It should match. See how x is smaller than 3? X is still smaller than 3. X is bigger than -1. Yes, x is bigger than the -1. So that would be a better way to write it algebraically. If I was going to write it in interval notation, I'd go -1 to 3 with parentheses. Okay, hope this helps out with inequalities. Good luck.